Hello everyone and welcome. Let me introduce myself. My name is Sergio Florea and I'm a forest engineer at Forest Design. Our goal at Forest Design is to be objective in our actions and make a change in the world by revealing the truth. I am part of a dedicated team of engineers, each with special abilities and much love for the great outdoors. Me and my team implement new emerging technologies into the forestry and environmental sector as these sectors lack digitalization. This material is focused on how geospatial analysis can be used to identify and integrate urban forest areas. Firstly, let me briefly clarify why do we need urban forest and what are the existing areas of urban forest. Urban forests can have a positive impact on cities and especially on their population. They can contribute to the physical and mental health of people by creating spaces for physical activity and buffering stress. In addition, they can improve air quality by removing harmful pollutants as well as reducing noise. From a social point of view, urban forests can support local livelihoods, enhance community cohesion, increase food security for marginalized communities, promote urban residents' connection to nature, and enhance equity. Every city needs urban green areas, and by law, every city has to have an urban green spaces plan, which is a part of the city development plan. City councils are engaging with experts who can analyze and identify such areas. But what are the existing areas of urban forest? The urban green includes forest, street trees, trees in parks and gardens, and trees in derelict corners. Green infrastructure consists of urban forests which connect rural and urban areas and improve a city's environmental footprint. For example, small land areas repurposed in pocket parks with trees and sittings can become spaces for social interaction. Therefore, urban forests consist of all trees and shrubs in urban areas. What are the existing areas of urban forest defined in the European Union? According to the World Health Organization, each person should have at least 9 square meters of green open space. This varies from country to country in Europe. For example, the Italian planning law requires 18 square meters of green space per person in new developments. The slide shows a map of public green space per inhabitant based on the city's population size across various European cities. Some cities are well in the green, but most of them are in the red. And according to current trends, in 2050, over 70% of the world population will live in urban areas, meaning that some towns will become green and others will turn red due to migration. The truth is that people will choose to live healthy in green cities. Considering the two images, which one is the best in terms of health benefits to human? The image on the left is the best, since it's not enough to have a large area of green and only grey infrastructure in the rest of the city. In order for urban forests to be within walking distance, no matter where you are, green infrastructure must be spread throughout the city. The question then becomes, how do we identify areas that can be transformed into urban forests? First, we take a look from the above using satellite imagery. To do so, we use the Earth Observation Portal website. With the EO browser, you can browse and compare full resolution images from all the data collection they provide. Simply browse to the area that interests you, select a time range and cloud coverage, and view the resulting data in different bands in the browser. Here is an example of a satellite view of the city of Tecuci, Romania, which will be used as a case study. In this view, it may not be obvious where the urban forest is located, but when we use the NDVI, the Normalized Difference Vegetation Index, we can see the white areas that lack vegetation. In these zones, the expert, which is conducting the analysis, should provide the municipality with a solution for greening the areas. The EO browser is extremely useful in providing the necessary overview for identifying and later overlapping satellite images over municipal urban development plans in a geographic information system. Now let's have a look at what a city's urban development plan is. Basically, it is a technical and political process that focuses on land use and the built environment, such as air, water, and the infrastructure going into and out of the cities, such as transportation, communication, and distribution networks. In addition to all the green space planning in a city, this plan also contains the local authority policies and proposals for land use in their area. The urban forest is an integral part of any development plan that aims to achieve sustainability and improve the health and well-being of its citizens. In order to identify areas without vegetation, we layered the NDVI image over the Urban Green Spaces plan. Data collected. We identified a suitable location by using satellite images as shown in the previous slides, and then look for urban forests in the field. After that, the decision is split between two options. If there are any green spaces, we measure and integrate them into an online map like that shown in the image. Furthermore, if there are no green infrastructure, we suggest the municipality to invest in green areas within those specific zones. The field stage is made using innovative technologies like terrestrial LiDAR, high-precision GPS, or classic methods like manual measurements. In order to integrate them into the city's urban development plan, the measurements consist of data about green infrastructure, such as trees, hedges, grass, flower beds, and other, and the places where they are located, the squares. Urban green space planning requires experts to gather data at an individual level, meaning a tree in a park is measured for height, diameter, health status, care status, GPS position, species, current number in the square, risk of falling, the potential damage if the tree falls, etc. The squares are surveyed for their facilities, sewage, sprinkles, electrical wires, and water pipes. The purpose of their utilization, green areas, alleys, fountains, and other, the surface condition, and what they contain, trash bins, flower beds, decoration, and so on. As the last step, the data collected about newly discovered areas and old areas that have been updated will be incorporated into the urban development plan. From all the data from the field, a customized database is created for every city. We developed an online platform that allows to visualize and manage the green spaces. This platform includes a set of functions that integrate green infrastructure itself, like trees, shrubs, squares, hedges, and other, key management documents, and a set of nomenclature like tree species, land use, risk, property type, regulation, ownership, and so on. As things always change in a city, the platform has the capability to be edited whenever new areas are introduced or the land usage is changed. Every city needs applications to monitor and continually improve the health and well-being of its citizens. In conclusion, the municipality can continue to implement the most effective measures for their citizens and invest in the benefits that come with the urban forest management. Thank you very much for watching.